Welcome to qnawire.
In this problem, you want to figure out the force that the walls are applying to the car. And it actually turns out that the force that the walls are applying to the car is equal to the normal force from the walls on the car. And so in part A, we have gravity pulling down, the normal force pushing up. We have a radial acceleration up, which is towards the center of the circle. And I orient my coordinate system so that the positive y direction is up. And so Newton's second law in this case gives the sum of the forces in the y direction is equal to the mass times the acceleration in y direction. This implies that the normal force minus mg, I have a minus here because it's in the negative y direction, is equal to mass times the acceleration in the radial direction. And the acceleration in the radial direction is just v squared over r. This must be an inequality there. And so the normal force is equal to mv squared over r plus mg. And now we can plug in the mass they give us, the velocity they give us, and the radius they give us. And when we do that, we get 61.76 newtons. So this is the force that the wall is putting on the car to keep it spinning in a circle. And so this is the answer they want. Part B, the situation is slightly different, but the approach is the exact same. Now the car is at the top. And so we have a normal force downward. We have an additional force of gravity also downward. So they're going in the same direction this time. We have an acceleration downward. And now the positive y direction I'm going to denote downward. So the sum of the forces in the y direction is equal to the mass times acceleration in y direction. Newton's second law, of course. And now N plus mg is equal to mass times the radial acceleration, which is still equal to v squared over r. And so now the normal force is equal to mv squared over r minus mg. And now plugging in these things again, we get 30.4 newtons. So when the car is at the top of the track, the walls are applying less of a force than when it's at the bottom. And that should make intuitive sense.